Good evening, children.
Good evening.
Good evening.
Good evening. Yeah, I think we finished 1 and 2 in the last class. Yes. Yeah, the third one. So you can see a figure, and in the figure, angle B is equal to 90 degrees. In the figure, angle B is equal to 90 degrees. C is the midpoint of BD. C is the midpoint of BD. BD is equal to A. BD, this full thing, BD is equal to A. And angle BAC is equal to theta. BAC, this one is theta. AD is equal to B. This is B. Okay. Find sine theta and cos theta. Find the values of sine theta. From this figure, find the value of sine theta and cos theta. All right. So since it's given that C is the midpoint of BD, CD will be A by 2 and BC will be A by 2, correct? Because C is the midpoint of BD, BD is A. C is the midpoint of BD. So BC and CD each will be equal to A by 2, half of A by 2. Like if the whole thing is 10 centimeters, BC will be 5 centimeters, CD will be 5 centimeters. So here it is A. So A by 2, A by 2. Now to find sine theta, theta is an angle in the right triangle ABC. Theta is an angle in the right triangle ABC. So if you have to define trigonometric ratios with respect to an acute angle in this triangle ABC, you need to know the sides of this triangle. Meaning you need to know the side AB, BC and AC, the hypotenuse AC. Theta is an angle of the right triangle ABC. That's the first thing. The sides of the right triangle ABC are AB, BC and AC. In order to define the T ratios with respect to angle theta of this triangle ABC, you need to know the sides of this triangle, the length of the sides of this triangle. So you need to find AB, BC you already know is A by 2, and you need to find AC. So that is the first task. You cannot directly, find sine theta and cos theta. To find sine theta and cos theta, you need to know the sides of the right triangle in which theta is an angle, in which theta is an acute angle. So now we'll first find AB. We'll first find AB using Pythagoras theorem. AB using Pythagoras theorem. How do you find AB? AB in right triangle ABD. In right triangle ABD, the whole triangle. In right triangle ABD, using Pythagoras theorem, because you know that this full thing is A. You know that this is A and this one is B. So using Pythagoras theorem in right triangle ABD, you can find AB. Now, once you find AB, you know that BC is A by 2. Now, in right triangle ABC, using Pythagoras theorem, you can find the hypotenuse AC because now you know this side and this side. So in right triangle ABC, using Pythagoras theorem, you can find AC. So like that, we'll find AB and AC. So now we have the lengths of all the three sides of the small right triangle ABC. Then go on to find sine theta and cos theta using the ratios. Sine theta is equal to opposite by hypotenuse, opposite side. The side opposite to theta by the hypotenuse. And cos theta is equal to the side adjacent to theta by the hypotenuse. Yes, help yourself. Start working. You may go through the slide first and then start working. I'll wait for 5 minutes. Excuse me. Yeah. Finish writing?
Now once again.
Okay. Is it over?
Yes, ma'am.
Okay. So you need to identify, the path, meaning how to start, how to find sine theta and cos theta. So the first thing is to identify the triangle in which the acute angle is. So the acute angle theta is in the right triangle ABC. So the next thing is, do you know all the sides of this triangle ABC? No, we know only BC. We don't know AB and AC. So there you know. So now that from there you realize that you should start off by finding a method to find the length of AB and AC. AB and AC. So you can find AB using the whole triangle, whole right triangle ABD using Pythagoras theorem, you can find AB. After finding AB, using AB and BC, you can find AC in the small right triangle, all using Pythagoras theorem. So here I'll tell you when it is root of B square minus A square, the whole square. So it's like square root of something into square root of something. So it's like, the square and the square root, they get cancelled. So it's B square minus A square. B square minus A square. It's like the square root and the square gets cancelled. So B square minus A square plus A square by 4. Common denominator is 4. So you get 4B square minus 4A square plus A square. Simplifying the like terms, minus 4A square plus A square is minus 3A square. Now 4B square minus 3A square in the numerator and 4 in the denominator. 4 is a perfect square. So you can bring that out of the square root. You can bring that out of the square root as 2. So the square root that's actually for the numerator and the denominator. But you see AC, we have used the square root only for the numerator because the square root of 4 is 2. The square root of 4 is 2. The square root of 4 is 2. So 2 comes out of the square root. And you can see that the numerator alone has a square root symbol. So that's the value of AC. That's AC. So we found AC now. We found AC. Now for theta, this is the opposite side. And this is the adjacent side. This is the hypotenuse because it's opposite of the right angle. That's the hypotenuse. So for theta, this is the opposite side and this is the adjacent side. So sine theta is equal to opposite BC by hypotenuse AC. And cos theta is equal to adjacent AB. You can see here adjacent AB by the hypotenuse AC. Now substitute the value. So whenever it's a fraction, I always use the division symbol so that you know how to calculate correctly. So this is BC. This is BC divided by this is AC. This is AC. This is BC divided by this is AC. So next step, division becomes into and reciprocal. Reciprocal. 2 and 2 gets cancelled. So A by root of 4B square minus 3A square is the value of sine theta. Similarly, cos theta, AB is this one. This is AB divided by AC. This is AC. So next step, division becomes multiplication and reciprocal of this one. Nothing gets cancelled. So 2 into the multiply the numerators. Multiply the numerators. 2 into this one. So 2 root b square minus a square by the denominator. So this is how you find the value of sine theta and cos theta. So identifying the triangle in which theta is an acute angle, and then identifying if you know all the lengths of all the three sides of that triangle. If you do not know, you have to find them, and then find sine theta and cos theta. If tan 2a is equal to, if tan a is equal to 2, find the value of sine a secant a plus tan a minus cosecant a. So remember, children, whenever you are given the value of one t ratio, you can find the values of all the other t ratios using a right triangle. Listen carefully. When you're given the value of one t ratio, so here tan a is equal to 2. Now, if you use this information, tan a is equal to 2 in a right triangle, you can find the values of all the other t ratios of a. You can find sine a, cos a, tan a. Sorry, tan a is given, cosecant a, secant a. That is one method, using the right triangle. So once you use the right triangle, you can find all these angles. You can find all this. Using the right triangle, you can find sine a, secant a, tan a, cosecant a. So see here, work this. I want to tell you something else. Please work this. I'll tell you an alternate method, not for this one, but I'll just share something else with you. Please complete this. So when tan a is equal to 2, that means it's 2 by 1. Tan a, please listen, tan a is equal to 2, meaning 2 by 1. So what is tan? So now you should use a right triangle, and a should not be the right angle. You should not mark a here. A is an acute angle. A is an acute angle. You should not mark a here as a right angle. No, a is an acute angle. So you can mark a here, or you can even mark a here. A can be any one of the two acute angles. So call the triangle ABC. Make sure that A is an acute angle. You can mark A here or here. A should not be the right angle. That's important. A should not be the right angle. So I've taken A here. Now tan A is equal, so I've marked it like this, ABC. So what is tan A? So with respect to angle A, this is the opposite side. For angle A, this is the opposite side and this is the adjacent side. This is the hypotenuse because it's opposite of the right angle. Now what does tan A connect? It connects the opposite side and the adjacent side. Tan A is equal to opposite BC by adjacent AB. So see here, tan A is equal to 2, meaning 2 by 1. 2 by 1. So tan A is equal to opposite. Opposite is 2 by adjacent 1. 2 by 1, no? This is opposite. This is adjacent. Tan A is equal to 2, meaning 2 by 1. Write 2 for the opposite side and 1 for the adjacent side. Then you can find the hypotenuse using Pythagoras theorem. The value of the hypotenuse using Pythagoras theorem will be root 5. You work if you want to show the steps. AC square is equal to BC square plus AB square. Work and you will see that AC is equal to root 5 by Pythagoras theorem. Now find the ratios. Sine A and the other ratios. Find with respect to angle A. Yeah, completed. So to evaluate this expression, you only need the values of sine A, secant A, tan A is already given, and cosecant A. To evaluate this expression, you only need these values: sine A, secant A, and cosecant A. So we'll find only them, substitute, and get the value. So how do you find sin A, children? Sin A is equal to, it connects with sides. Don't know? Yeah, children, tell me. Sin A connects
Opposite by hypotenuse, ma'am.
opposite by hypotenuse. Sin A is equal to opposite by hypotenuse. So which is the opposite side? BC. By hypotenuse AC. BC by AC. Hypotenuse, you found it's root 5. Hypotenuse is root 5. We worked using Pythagoras theorem. So 2 by root 5. Why sin A is 2 by root 5? Sin A is equal to opposite BC by hypotenuse AC. So 2 by root 5. Secant A is hypotenuse by adjacent. Secant A is equal to hypotenuse by adjacent. Hypotenuse AC root 5 by adjacent AB, which is 1. And cosecant A is the reciprocal of sin A. Cosecant A is the reciprocal of sin A. So root 5 by 2. So once you get all these values, take up the expression which is to be evaluated. Substitute the values. Yeah. Complete this. Done, children?
Yes, ma'am.
Yeah. So the opposite and adjacent sides are not fixed. The opposite and adjacent sides are not fixed. So with respect to this angle, with respect to this angle A, for angle A, this is the opposite side and this is the adjacent side. For angle C, this is the opposite side and this is the adjacent side. For angle C, this is the opposite side and this is the adjacent side, the side opposite to angle C. And the side, now you will say this is also adjacent to C. No, this is already the hypotenuse. So you are not deciding, you're not using the side at all. This is the hypotenuse. So there are only two sides left. One side of the three sides, one is the hypotenuse. Now you will have to decide only between these two sides. For angle C, this is the opposite side. So this becomes the adjacent side. Okay. Now here you will not find this value 2 in the table. So in the table, you know, for tan 0 degrees. So you have 0 degrees, 30 degrees, 45, 60 and 90. Okay, so tan 0 is 0, tan 30 is 1 by root 3, tan 45 is 1, this is root 3, this is not defined. Now you don't find 2. You don't find 2 here. You don't find 2. Tan A is equal to 2. You don't find that value 2 here. So you have to use a right triangle. So you have to use a right triangle. Now, supposing the value of tan A, the value of tan A is given to be 1 by root 3, for example. Okay, tan A is equal to 1 by root 3 is given to you. So if tan A is equal to 1 by root 3, the tan A is equal to, instead of root 3, what can you write? Tan 30 degrees. Instead of 1 by root 3, you can write tan 30 degrees on the other side. Tan A is equal to 1 by root 3. Instead of 2, if it is given 1 by root 3. So tan A is equal to 1 by root 3 can be written as tan 30 degrees. So tan of A is the angle. Tan A is equal to tan 30 degrees. That means on comparing both the sides, A is equal to 30 degrees. A is equal to 30 degrees. So you can find the angle. If the value is one of the standard values here, you can find the angle itself. So tan A is equal to 1 by root 3 can be written as tan 30. On comparing both the sides, you cannot cancel tan and tan. You cannot cancel. On comparing both the sides, A is equal to 30 degrees. Now that you know A is 30 degrees, what should you evaluate? You don't have to use a right triangle in that case. You don't have to use a right triangle in that case. What do we have to evaluate? So this is how you present. So tan A is equal to 1 by root 3 is given, but we know that tan A is equal to tan 30 degrees. So on comparing both the sides, A is equal to 30 degrees. Now we have to evaluate sin A secant A plus tan A minus cosecant A. But we know that A is 30 degrees. That means we'll have to find sin 30 degrees, secant 30 degrees plus tan 30 degrees minus cosecant 30 degrees. Now you can pull the values from the table. What is the value of sin 30? 1 by 2 into secant 30 degrees. So secant 30 meaning what is cos 30? Root 3 by 2. So secant 30 will be 2 by root 3 plus tan 30 1 by root 3 minus cosecant 30. Cosecant 30 is a reciprocal of sin 30. So what is sin 30? 1 by 2. So cosecant 30 will be 2, the reciprocal 2. Just remember the values for sine, cos, and tan. Sine, cos, and tan. Remember the values for sine, cos, and tan. If you want to find cosecant, sometimes what children do is, you can even write down the entire table in your, exam paper. So you can refer to the values every time. Somewhere if you make a note of the, somewhere if you write down the table, then you can just refer. Otherwise, if you want to think every time, you can just remember sine, cos, and tan. Reciprocals like this. So if you want to find cot of an angle, find that, recall what is tan of that angle. So whatever is tan of that angle, reciprocal will be cot. So like this, you can substitute the values, then it's just simplification, you have to, this gets cancelled 1 by root 3. This is just for an example. 1 by root 3 plus 1 by root 3 minus 2, then LCM and all that. Whatever. Okay, then if the denominator is irrational, rationalize the denominator. So what is that you've understood now? If the value is a standard value, tan A is equal to, supposing it's given root 3. If this is a standard value, if you can find this value in the table, then you can find the angle itself. So you should say tan A is equal to, what is root 3, children? Tan of what angle is root 3? At least refer and tell me.
60 degrees.
60 degrees. So tan 60 degrees is root 3. So on comparing both the sides, A is equal to 60 degrees. So we found A. So we have to find now sine 60 degrees, secant 60 degrees, plus tan 60 degrees, minus cosecant 60 degrees, because A is 60 degrees. We found A. Now, how do you continue? From the table, you can get these values. What's the value of sine 60 from the table? Secant 60 from the table. So substitute the values and then simplification. And always if the denominator is irrational, rationalize the denominator. That's all. If you cannot find the value in the table, if you cannot find the value, like in this case, 2, no, we don't find 2 in the table, then you cannot make out the angle. In that case, use the right triangle. Use the right triangle. In that case, use the right triangle. What is secant A we got, children? What is secant A? Root 5, right? Have you all written this answer in your notebook?
Yes, ma'am.
No.
Okay. So we can also find these values using algebraic identities. There's another method. This is another method. You can also find these values using algebraic, trigonometric identities. Okay, if I said algebraic identities earlier, I'm sorry. So you can also find these values, sin A, secant A, tan A, cosecant A, using trigonometric identities. All right, so now let's do that. Now we know that secant square A minus tan square A is equal to 1. Yes or no? Well, if you say yes or no.
Yes, ma'am. Yes, ma'am.
Tarun Murali?
Yes, ma'am.
Yeah. Have you watched all the videos on trigonometry, Tarun Murali?
I'm only few.
You watched?
I'm only few, ma'am.
Only few, huh?
Ma'am, I'll try to finish it later, ma'am.
What about Sneha and Harini? Have you watched all the videos?
Ma'am, no, ma'am. Last class video we didn't watch, ma'am. Today night we are going to watch.
No, not that. The YouTube videos I had shared on introduction to
Yes,
trigonometry.
ma'am. That we have seen, ma'am.
Ramnathan,
Yes, ma'am.
Rajeshwari, Rajeshwari,
Yes, ma'am.
Pranav Rajan, Nandini.
Ma'am, I didn't watch the last two videos, ma'am.
Last two you have not watched. Murali Krishna,
Ma'am, 3 videos, ma'am.
Kanishka, Kanishka, Ananya.
I think I have 2 to 3 videos left, ma'am. I'm not sure. I watched it when you gave the assignment.
Okay, and what about Hitesh?
Last 2 videos I have to watch it, ma'am.
Okay. All right. Now, raise your hand, children. How many of you following the class? Ramnathan, Nandini, Ananya, Rajarajeshwari, Hitesh, Tarun, Murali Krishna, Sneha, Harini, Kanishka, and Pranav. I don't know. Okay. All right, children. So this is the identity. Now, why are we using this identity? Because we know the value of tan A. Because we are given the value of tan A. So when we use this identity, secant square A minus tan square A is equal to 1. Secant square A minus tan square A. I told you tan square A is nothing but tan A into tan A. Tan A into tan A. Meaning tan A the whole square. Tan A the whole square is written as tan square A. Tan square A is nothing but tan A into tan A. Tan A the whole square is tan square A. So what is the value of tan square A? Tan A into tan A. So nothing but 2 the whole square. Tan A is 2. So tan square A is the square of that. 2 square is equal to 1. Secant square A minus 4 is equal to 1. Secant square A is equal to 1 plus 4, 5. So secant A is equal to square root of 5. That's it. It's not a perfect square. So secant A is equal to square root of 5. So see here, we got that only here. Secant A is equal to square root of 5. So you can find the other t ratios using a right triangle. Using a right triangle. If the value is a standard value, if you can find that value in the table, you can find the angle straight away. You can also use trigonometric identities. So which identity to use? Since we are given the value of tan A, and we have tan A in this identity, secant square A minus tan square A is equal to 1. You can use the value of tan A here and find the value of secant A. Now, what are the other ratios we have to find, children? What are the other ratios we have to find to evaluate this expression?
Sin A and cosecant A.
Sin A and cosecant A. Now, what if you know secant A? What is that you can find immediately? With secant A, what can you find? What is the reciprocal of secant A? Which ratio is the reciprocal of secant A? The reciprocal of secant A. Yes, Ananya, you can answer. No, you've learned this chapter in full in school. Please tell me. Yeah.
Cos A, cos A.
I'm so sorry, I can't hear you clearly.
Cos A, ma'am.
Cos A. So what's the value of cos A?
I'm still not thorough with the table.
No. It's not about the table, children.
1 by root 5, ma'am. 1 by root 5.
1 by root 5. 1 by root 5. Children, when you have the value of tan A, that you have the value of cot A. If tan A is 2, cot A is 1 by 2. If secant A is root 5, cos A is 1 by root 5. Tan A is 2. So what's the value of cot A?
1 by 2.
1 by 2. Now we found secant A is root 5. So what's the value of cos A?
1 by
1
root
by
5.
1 by
1
root
by
5.
root 1 by root 5. Now you have to find sin A and cosecant A. So it's enough if you find cosecant A or sin A because they're reciprocal ratios, sin A and cosecant A. If you find sin A, you can take the reciprocal of that value and that will be cosecant A. Or you find cosecant A, its reciprocal is sin A. So it's enough if you find sin A or cosecant A. Now tell me which identity to use to find sin A or cosecant A, whatever. You want to find cosecant A, we'll find. You want to find sin A, we can find. So supposing you want to find cosecant A, you should use the identity cosecant square A minus cot square A is equal to 1. Now cosecant square A minus cot square A. Tan A is 2. So cot A is 1 by 2. Cot square A is 1 by 2, the whole square is equal to 1. Cosecant square A is equal to 1 plus 1 by 4. Cosecant square A is equal to 5 by 4. Cosecant A is equal to square root of 5 by 4. Cosecant A is equal to root 5 by 2. See here, cosecant A is equal to root 5 by 2. So what do we understand? We can find, given one t ratio, we can find the other t ratios using a right triangle. If the value is a standard value, which is found in the table, you can find the angle straight away. And supposing the angle is 45 degrees, we have to evaluate sine 45, secant 45 plus tan 45 minus cosecant 45. And these values you can get from the table, substitute and simplify. So you can use a right triangle or you can find the angle if possible, or you can use trigonometric identities like this. With one ratio, you can use the appropriate identity. Whichever identity has that value which is given, tan A, secant square A minus tan square A is 1. You can use this identity and find secant A. So now you have tan A, that means you have cot A. With secant A, you have cos A also, it's reciprocal. Now sine and cosecant. So you decide if you want to find cosecant A, use this identity, cosecant square A minus cot square A is 1. So you have cosecant A, its reciprocal is sine A, 2 by root 5. See, that's what we got here also using the right triangle. That's what we got here using the right triangle. You can use sine square A. You can also use this. Sine square A plus cos square A is 1. You can also use sine square A plus cos square A is 1. Right. So see here, sine square A plus cos square A is equal to 1. So we are trying to find sine square A plus cos square A. You can see it there, 1 by root 5. 1 by root 5 the whole square is equal to 1. Can you see here? Cos A is 1 by root 5. Cos A is 1 by root 5. So cos square A is 1 by root 5 the whole square is equal to 1. So sine square A plus 1 by 5. 1 by root 5 into 1 by root 5 is 1 by 5 is equal to 1. So sine square A is equal to 1 minus 1 by 5. 1 minus 1 by 5, which is 4 by 5. 4 by 5. So sine A is equal to square root of 4 by 5. Sine square A is 4 by 5. Sine A is equal to square root of 4 by 5. Square root of 4 by 5 is square root of 4 is 2. And square root of root 5 is root 5 itself. 2 by root 5. Sine A is equal to square root of 4 by 5. Square root of the numerator is 2. Denominator is root 5 itself. So 2 by root 5. So we found sine A, 2 by root 5. Cosecant A is root 5 by 2. So all of you make a note of this. We can find, given one T ratio. Let me clear the slide and write. Given one T ratio, this is, like a layman's language, okay? Don't, just for us to understand. So given one T ratio, we can find the others using a right triangle, or if it's a standard value, you can find the angle, or you can use a right triangle, or you can find the acute angle itself. You can find the measure of angle A. If possible, that you cannot always, only if it's a standard value, you can do it. But this you can always use. You can always use a right triangle. You can always use trigonometric identities. This one only if it's of standard value. If you can find that value in the table, otherwise you cannot. But 1 and 3 you can always do. Children, be sincere now. Lower your hands and raise your hand if you understood this much. Write down this in your book. Yeah, now lower your hands, all of you. Raise your hands. Lower your hands, children.
Mom, can you show the slide again, Mom?
What slide?
Mom, you wrote no, Mom.
Yeah. Done? Yeah, class now. Raise your hand if you understood so far. Hitesh, I would like to help you. You have a doubt? Yeah. So I told you, children, because it's a vast chapter, I just wanted to give you a feel of the whole chapter, which is why this presentation has assorted questions. Okay, so now look at this. If sine of a plus b plus c is equal to 1, sine of a plus b plus c is equal to 1. Now, all of you look into your book, you have completed the notes, right? Flip the pages, go back and see in the sine table, when do you find the value 1? When is it 1 in the sine table? Fast.
90 degrees.
Sine 90. Sine 90. You should not write just 90 degrees. Sine 90 degrees is 1. What is 1? Sine 90 degrees is 1. So 1 can be replaced with sine 90 degrees, not just 90 degrees. 90 degrees is not 1. Sine of 90 degrees is 1. So you can replace 1 with sine 90 degrees. So instead of 1, I'm writing sine 90. Correct?
Yes, ma'am.
Yeah, now when you compare both the sides, what do you get? What do you get when you compare both the sides? See, sine, this is an angle. A plus B plus C, when you add, you will get one angle. You will get one value. When you add A, B, and C, you will get one.
30 degree, Mom.
Yeah, who's that louder?
A plus B plus C is equal to 90 degree, Mom.
On comparing both the sides, A plus B plus C is equal to 90 degrees. See here, 90 degrees. Now, similarly, next information. What is given? Yes, class. What's the next thing given?
30 degree.
Tan of
A
what? A minus B is equal to 1 by root 3. And as Tarun said,
Tan 30.
30 degrees is 1 by root 3. So instead of 1 by root 3, write tan 30. On comparing both the sides, A minus B is equal to 30 degrees, correct?
Yes, ma'am.
Yeah. Then secant of A plus C is equal to 2. When is it 2 in the secant table?
60 degree, ma'am.
Secant 60 degrees. Because 1 by 2 in cos table is cos 60 is 1 by 2. So secant 60 is 2. Secant 60. So on comparing both the sides, A plus C is equal to 60. Now see, we have got it's like x plus y plus z is equal to 90. X minus y is equal to it's like that. You don't have to use x and y. And then x plus z is equal to 60. So we know how to solve equations. We just have to solve these equations and get the values of A, B, and C. See here. So here the idea is, what I have done is, I've called this equation 1. And everywhere, see here, I've written B in terms of A. I've written B in terms of A and C in terms of A. I've written B and C in terms of A. B is equal to A minus 30. C is equal to 60 minus A. Now substitute B and C in the first one. In place of B, use A minus 30. And in place of C, use 60 minus A. So what happens? This equation, we have only one unknown A. This equation will have only one unknown A. So you can find A and then find B and C. I'll repeat about the idea here. I've written B in terms of A minus 30. So this B is A minus 30, A minus 30. And I've got C also in terms of A, 60 minus A. That means the C is 60 minus A, 60 minus A. Now, if you see this equation, there is only A. So you can solve this one and find the value of A. Once you find A, you can find B and C. Work this, children, fast.
Ma'am,
Yeah.
ma'am, C is equal to 30, B is equal to 0, ma'am.
Oh, I've gone wrong. Oh. No, but.
Oh, ma'am, correct, ma'am. Sorry.
Okay, no problem. Done, children? All right. See the next one. Evaluate cot theta tan 90 minus theta minus secant 90 minus theta cosecant theta plus sine square 65 degrees it is everywhere, plus sine square 25 degrees plus root 3 of tan 5 degrees, tan 45 degrees, tan 85 degrees. Now, this one involves complementary ratios. Now, cot theta, let's write it as it is. Now, what is tan 90 minus theta? Look into your book and tell me. Don't search. Don't use Google. Please look, use your book. You've all submitted the assignment on trigonometry. Use your notebook. Tell me what is tan 90 minus theta? Complementary ratios. Yes, be quick, children.
Cot theta, ma'am.
Cot theta. Tan 90 minus theta is cot theta. So into cot theta minus what is secant 90 minus theta?
Cosecant theta, ma'am.
Cosecant theta. Cosecant theta. And that cosecant theta, we write it as it is. Cosecant theta, that is into cosecant theta plus. Now here we have to use an algebraic, oh my God, sorry. Here we have to use a trigonometric identity. So sine square 65, see a sine square, can you see that sine square 65? Realize that 65 is not a standard angle. 65 is not a standard angle. You cannot get its value from the table. If it was sine square 45 degrees, you can get the value from the table. It's sine square 65. 65, we don't know the value. Sine 65 has a value. From the table, we cannot get it because it's not a standard angle. So you have to do something else. So sine square 65 plus sine square 25 we have. Now children, we know that sine square theta plus cos square theta is 1. Cos square theta is 1. Sine square theta plus cos square theta is 1. Now we know that sine theta is equal to cos 90 minus theta. When you square this on both the sides, you get sine square theta is equal to cos square 90 minus theta. I repeat. See, one thing is sine square theta plus cos square theta is 1. Now you can't say that sine cube theta plus cos cube theta is 1. How can you say this? See, you use sine square theta plus cos square theta is 1. Do something meaningful and get some other relation. That's fine. But from this sine square theta plus cos square theta is 1, you cannot write sine cube theta plus cos cube theta is 1 like this. You cannot keep going like this. Cos to the power 4 theta is equal to 1. No, all this is meaningless. This is the identity. You can square it on both the sides. You can do any meaningful mathematical operation and get other equalities. But simply changing the square to cube, you cannot do these changes. Similarly, now what did I show? I said sine theta is equal to. I said sine theta is equal to cos 90 minus theta. So you know this. Now what are we doing? We are squaring on both the sides. What are we doing? We are squaring on both the sides. Yeah, we can do that, right? We can square on both the sides. Okay, so let's square on both the sides. What is sine theta the whole square? Sine square theta. Cos 90 minus theta the whole square. Cos square 90 minus theta. So it's valid. So sine square theta is cos 90 minus theta. Sine square theta is cos square 90 minus theta. So what we're going to do is, let's write sine square 65 as it is. Anything you can change. You can change sine square 65 or sine square 25. Let me do one for you. So now we'll write sine square 25 as, what is sine square theta? Cos square 90 minus theta. See here, look at this. Sine square theta is cos square 90 minus theta. So instead of sine square 25, instead of sine square 25 degrees, see, we can write it in two different ways. I'll do one for you now. Now tell me, what is, you can tell it yourself. What is sine square 25? It's cos square what, children? Cos square?
90 minus 25.
90 minus 25 because theta is 25 degrees. Because theta is 25 degrees. So sine square 25 is equal to cos square 9. Theta is 25. So wherever there is theta, use 25. That's all. So plus cos square 90 minus 25. I'm using this. Plus, I'm continuing below here, root 3 into, let's group tan 5 degrees and tan 85 degrees because 5 and 85 make 90. You'll have to group like that when they're not standard angles. 5 and 85 are not standard angles. When they're not standard angles, you group so that the sum is 90 degrees. So 5 plus 85 is 90. So we'll just pair them. And tan, see, it's a multiplication everywhere. So tan 5, tan 85 we pair. And tan 45 we leave it alone because we can get its value from the table. So we are done analyzing now. Now next step, cot theta into cot theta is cot square theta minus cosecant theta into cosecant theta is cosecant square theta. plus sine square 65 as it is, plus what is 90 minus 25? 65. So cos square 65. So now we have got sine squared 65 degrees plus cos square 65 degrees, like sine square theta plus cos square theta. Theta is the same, 65 in both. So we know sine square theta plus cos square theta is 1, which means sine square 65 plus cos square 65 is 1. The value of this is 1. So done with this part. Sine square 65 degrees plus cos square 65 degrees is 1 because we have the identity. Sine square theta plus cos square theta is 1. So this is 1. Done. Then we have to continue with this one. Plus root 3 into. Now you can change tan 5 degrees or tan 85 degrees. To what? I'll tell you. Now supposing you want to change tan 5 degrees. Sorry, tan 85 degrees. What is tan 85? What is tan theta? Cot 90 minus theta. What is tan theta? Cot 90 minus theta. So tan 85 degrees is cot 90 minus theta. 90 minus 85 degrees. So we're just using that relation which we already know. Trigonometric ratios of complementary angles. Tan theta is equal to, so tan 85 is equal to cot 90 minus theta. Cot 90 minus 85. 90 minus 85. See here, tan 85 is equal to cot 90 minus 85. You can, instead of tan theta, you can write cot 90 minus theta. If you have tan theta somewhere, you can take that away and write cot 90 minus theta. Both are the same. So I'm writing tan 85 degrees as cot 90 minus theta, 85 degrees. And tan 45, the value from the table is 1 into 1 into 1. Now come from the beginning. Cot square theta, I'll tell you what to do with this. Actually, you can do that in this step itself, but I'm not doing it for you. Cot square theta minus cosecant square theta plus sine square theta plus cos square theta is 1 plus root 3 into tan 5 degrees into cot 5 degrees because 90 minus 85 is 5. Cot 5 degrees. Cot 90 minus 85 is 5. And into 1. So you can just leave it into 1. No, so you can just omit it. Now use reciprocal ratios. Now use reciprocal ratios. What is cot 5? 1 by tan 5. What is cot theta? 1 by tan theta. What is tan theta? 1 by cot theta. Reciprocal ratios. Tan theta is the same as 1 by cot theta. Tan theta and cot theta are not the same. Tan theta can be written as 1 by cot theta. 1 by cot theta, 1 by tan theta is cot theta. Reciprocal ratios. If you have tan theta, you can replace that with 1 by cot theta. Or if you have cot theta, you can replace that with 1 by tan theta. These two are equal. Now here we have what? Cot 5 degrees. So cot 5 degrees, anything you can replace using using reciprocal ratios. You can replace this or this using reciprocal ratios. Any one you can replace. Okay. So supposing you want to replace this one, this cot 5 degrees. So actually here what you'll have to do is you'll have to take out minus common and write cosecant square theta first. Cosecant, because we know cosecant square theta minus cot square theta is 1. So take a minus outside. Cosecant square theta minus cot square theta plus 1 plus root 3 into here. Supposing you want to replace tan 5. Tan 5 is 1 by cot 5. Tan theta is 1 by cot theta. So tan 5 degrees is 1 by cot 5 into cot 5. Close it. So now this cot 5 and cot 5 will get cancelled. Will get cancelled. Then we have all numerical root 3, 1. And here you understand when you take a minus, there will be minus cosecant square theta. Minus into minus is plus cot square theta. And cosecant square theta minus cot square theta is 1. Now everything is numerical, simplify. Right on. So we're using to evaluate this expression, we use an algebraic. Oh my goodness. We used a trigonometric identity. Sine square theta plus cos square theta is 1. We also use the concept of complementary ratios. We also use the concept of reciprocal ratios. See, all in this one question. Good. Finish writing, children?
Yes, ma'am.
Okay. So let's see it again. Cot theta, as it is cot theta. Tan 90 minus theta. If you look into the trigonometric ratios of complementary angles, you will see that tan 90 minus theta can be written as cot theta. So cot theta again. And cot theta into cot theta is cot square theta. A into A is A square. Cot theta into cot theta is cot theta the whole square, which is written as cot square theta. Then minus secant 90 minus theta. Again, trigonometric ratios of complementary angles. Secant 90 minus theta can be written as cosecant theta. Cosecant theta is equal to secant 90 minus theta. Secant theta is equal to cosecant 90 minus theta. So secant 90 minus theta we have. That can be written as cosecant theta. And this cosecant theta as it is. So there is no sign in the middle. That means it's multiplication. Cosecant theta into cosecant theta. There's no sign here. See here? There's nothing here. So it's into multiplication. Cosecant theta into cosecant theta is cosecant square theta. So let me finish with this. We know that cosecant square theta minus cot square theta is 1. It's easy to remember the identities like this. Is equal to 1 in all the three. So cosecant square theta minus cot square theta is 1. But here we have what? We have cot square theta minus cosecant square theta. We have it the other way. So we take a minus common here. We take a minus common, minus, and then you can write this first and then this. How to understand that? You multiply and see. Minus into cosecant square theta is minus cosecant square theta. Minus into minus plus cot square theta, plus cot square theta. You should understand this, but let's say, no, you should understand this. An alternative is, you can write cot square theta. You can write cot square theta. What is cot square theta? What is cot square theta? Cosecant square theta minus 1. You can write cot square theta as cosecant square theta minus 1. So you can take away this, and in the next step you can write cosecant square theta minus 1. So then what will happen? Cosecant square theta minus cosecant square theta will get cancelled, and then you will get minus 1. So you have different ways of doing it. I'm talking only about this first part. I'm talking only about this first part. Cot theta into cot theta is cot square theta. Cosecant theta into cosecant theta is cosecant square theta. I'm talking only about this one. One way is you can take out minus common and write it like this, and cosecant square theta minus cot square theta is 1. So you get minus 1. That's one way. Otherwise, you can take away cot square theta and write that as, see here, cosecant square theta minus cot square theta is 1. So if you take this cot square theta to this side, what do you get? Cosecant square theta minus 1 is equal to cot square theta. So instead of cot square theta, you can write cosecant square theta minus 1. You can write cosecant square theta minus 1. So next step, instead of cot square theta, write cosecant square theta minus 1. Then what happens? Minus cosecant square theta plus cosecant square theta gets cancelled, and you'll get minus 1. So that's about this part. You can also write cosecant square theta as 1 plus cot square theta. Then also you can write this one as 1 plus cot square theta in a bracket, because there's a minus here. So you should put it in a bracket. So if you can visualize it, you will get minus cot square theta when you multiply the minus sign. So plus cot square theta minus cot square theta will get cancelled, and then this minus 1. Like that, we evaluate this one. Now talking about this part, sine square 65 and sine square 25, why we should use an identity is because 65 degrees and 25 degrees are not standard angles. 30 0, 30, 45, 60, 90. No 25, no 65. They're not standard angles. So you cannot get their values from the table. Then you should find some other way of dealing with this. And that is using an appropriate trigonometric identity. So you want to write this one as sine squared theta plus cos squared theta is 1. So you fix the plan. You get the plan and then you execute it. See, if the first step is completely numerical, you don't have to think. You have to keep working. See, there are two ways. Certain situations are like like supposing you're solving a quadratic equation. You cannot plan it fully. You're solving a quadratic equation. So you can work the next step. That next step will tell you what to do next. Then it will tell you what to do next. So sometimes we have to start working and one step will lead to the other. But sometimes you'll have to plan what to do. Now here you'll have to plan how to proceed with this. So you have to identify that. So here we have to use the identity sine square theta plus cos square theta is 1 and modify this expression to suit that identity. And modify this expression, this expression sine square 65 degrees plus sine square 25 degrees to suit that identity. So what we do is we decide to keep the sine square 65 as it is. And we want to change this to cos square something, cos square 65. So we write sine square theta. We know that sine theta is equal to cos 90 minus theta. So sine square theta is equal to cos square 90 minus theta. So sine square 25 degrees is equal to cos square 90 minus 25 degrees. So we write cos square 90 minus 25 degrees. Sine square 25 is cos square 90 minus 25. So we are done with this also. Now this is going to become cos square 65 in the next step. And sine square theta plus cos square theta is 1. So we are done with this also. So this part is over. This part is over. Now the last part, this one, the last part. So here tan 45 degrees standard angle is 1. So that also we have the value. Root 3 is a constant. Root 3 is root 3. So nothing to do there. So we have to work on tan 5 and tan 85. Why did we group tan 5 and tan 85? Because 5 plus 85 is 90. So we group the ratios where the angles add up to 90 degrees. So we group tan 5 and tan 85. Now how to handle this? So first we use complementary ratios, or you can use reciprocal ratio first and then complementary ratio. Any way you can do it. So I've used complementary ratio first. So I decided change one of the two. So I took up tan 5, tan theta is equal to cot 90 minus theta, 90 minus theta. So then if theta is replaced with 5, tan 5 degrees is equal to cot 90 minus 5 degrees. So that's what you see here, cot 90 minus 5. Cot 90 minus 5. Then don't change both, right? Tan 85 as it is. Right? Tan 85 as it is. Now 90 minus 5, subtract, you will get 85. You will get cot 85. Now write tan 85, reciprocal. Tan 85 is tan theta. Tan theta is equal to 1 by cot theta. 1 by cot theta. So theta is 85. Tan 85 degrees is equal to 1 by cot 85 degrees. So 1 by cot 85. Now cot 85 gets cancelled. Now everything is numerical. Simplify that. So first you need to, look at the expression given, the expression whichever is to be evaluated. You'll have to look at it and come up with ideas and execute that. If you're given a pair of linear equations in X and Y, so you look at it and you see that the coefficients are exchanged. So immediately, you have to use a special method. So you'll just start working. You will not think anything beyond that. You will add the two equations. You will subtract the two equations. So you start working and one thing leads to the other and you complete it. Here, it's not like that. You will have to look at the expression and analyze the different parts of the expression, get the idea and execute that. See, you should first get that idea that here, this part, we have to evaluate using the identity sine square theta plus cos square theta is 1. And then you should execute that. You cannot just start working. Every part you will have to analyze, get the idea, understand, decide as to how to proceed and then execute that. If sine theta plus cos theta, all if you finish working this, right? Say yes.
Yes,
or
ma'am.
no? Yeah, thank you.
Yes.
All right, children. The next one. If sine theta plus cos theta, lower your hands, class. Hitesh and Pranav. Hitesh, are you there? Kanishka? Yeah. So here sine theta plus cos theta. Sine theta plus cos theta is equal to root 2 sine 90 minus theta. So next step, sine theta plus cos theta is equal to root 2 sine 90 minus theta is cos theta. Sine 90 minus theta is cos theta. Cos theta. Now we can't do anything much. Now we'll try to gather the like terms. Here we have cos theta. Here also we have cos theta. So let's just try this. Sine theta is equal to root 2 cos theta minus cos theta. Minus cos theta. Transposing plus cos theta. Why? The idea is, they're like terms. Like terms meaning both are in terms of cos theta. So let's see what we can do with that. So sine theta is equal to, you can take out cos theta common. And in the bracket you will get, what? If you take out cos theta common, in the bracket, root 2
Minus 1.
minus 1. Now transpose cos theta to the LHS. Transpose cos theta to the LHS. So it will be what?
Sin theta by cos theta, ma'am.
By cos theta. Sin theta by cos theta is equal to what?
Root 2 minus 1, ma'am.
Root 2 minus 1. What is sin theta by cos theta? What is sin theta by cos theta?
Tan theta, ma'am.
Tan theta. Sin theta by cos theta is tan theta. Tan theta is equal to root 2 minus 1. What is the reciprocal of tan theta? 1 by cot theta. Tan theta is equal to root 2 minus 1. So what will be the value of cot theta? If tan theta is root 2 minus 1. Or what you can do is you can take reciprocals on both the sides. Supposing you can take reciprocals on both the sides. So you will get 1 by tan theta. Taking reciprocals on both the sides. 1 by tan theta is equal to 1 by root 2 minus 1. So now what is 1 by tan theta? Cot theta. What is 1 by tan theta? Cot theta. See, first I take reciprocals on both the sides. Tan theta, I write it as 1 by tan theta. Root 2 minus 1, I write it as 1 by root 2 minus 1. Taking reciprocals on both the sides. Now 1 by tan theta is cot theta. Cot theta is equal to, don't change this. 1 by tan theta is equal to cot theta. So we're just replacing 1 by tan theta with cot theta is equal to 1 by root 2 minus 1. The denominator is irrational. So you'll have to rationalize it. So into root 2 plus 1 by root 2 plus 1. So the numerator is root 2 plus, multiply the numerators root 2 plus 1 by denominator. When you multiply root 2 minus 1 into root 2 plus 1, a plus b into a minus b, a square minus b square. So cot theta is equal to cot theta is equal to root root 2 plus 1 divided by a square, root 2 the whole square, plus, sorry, minus b square, 1 the whole square. So cot theta is equal to root 2 plus 1 divided by 2 minus 1, 2 minus 1. So cot theta is equal to root 2 plus 1. Because 2 minus 1 is 1. So cot theta is equal to root 2 plus 1. We have to find the value of cot theta. And the value of cot theta is root 2 plus 1. Write down, children. Write down, all of you. Yeah, finished?
Yes, ma'am.
Yeah, complete this in your book. You can understand this one. Yeah, take a screenshot and finish it. So it's a right triangle. You just have to find sine A and secant C. So remember, sine A and secant C. For A, opposite and adjacent will be different from C. When you're finding for angle A, for angle A, this is the opposite side. And this is the adjacent side. This is the hypotenuse because it's opposite the right angle. For angle C, this will be the opposite side. For angle C, this is the opposite side and this is the adjacent side. So be careful when you're using the ratios. Opposite and adjacent, see, you'll have to find sine A and secant C. So sine A will be opposite by hypotenuse. Secant C, hypotenuse by adjacent. This is C. Hypotenuse is this by adjacent. For C, this is the adjacent side. So hypotenuse by adjacent. And when you have to find ratios like this, you need to know all the sides of the right triangle. You know that. When you have to find these ratios, you need to know all the sides. So this is a simple thing. You've learned, you must have seen it in standard 8. So find the sides and find the ratios. Yeah, complete this, take a screenshot. Yeah, this is also important. Yeah, this one. Yeah, with this we'll wind up the session, children. I'll just 8, you took a screenshot. 9, I'll just tell you how it goes. You can finish it. Yeah. So in 9, children, I just need 2 minutes to say this. Please wait. So in 9, children, we know that secant square theta minus tan square theta is 1. Okay. Now this is in the form a square minus b square, which is a plus b into a minus b. Secant theta plus tan theta into, okay, I've worked it here. So secant theta plus tan theta into secant theta minus tan theta. Sorry. Okay, so see here, secant square theta minus tan square theta is 1. Yes. Now this is in the form a square minus b square. So it is a plus b, secant theta plus tan theta into a minus b, secant theta minus tan theta is equal to 1. See, this identity we write by ourselves. Nowhere there's a clue that we have to write it. We write it by ourselves. Secant square theta minus tan square theta is 1. A square minus b square. So a plus b into a minus b is 1. Now we are given that secant theta plus tan theta is p. So p into secant theta minus tan theta. See, this one is p. Secant theta plus tan theta is p. It's given. It's given. Into secant theta minus tan theta is 1. So secant theta minus tan theta is equal to 1 by p. This p comes to the other side for division. So 1 by p. 1 by p. Please write this here. Secant square theta minus tan square theta is equal to 1. You'll have to write that. So using this identity and you treating this as a square minus b square, we get a plus b into a minus b is equal to 1. But we know that this is p. This is p. Secant theta plus tan theta is p. So into secant theta minus tan theta is 1. So secant theta minus tan theta is equal to 1 over p. So now see, we know that secant theta plus tan theta is p. And now we have found secant theta minus tan theta is 1 by p. Secant theta plus tan theta is p. Secant theta minus tan theta is 1 by p. So now what we're going to do is we're going to work these two in the linear style, like how we solve two equations in x and y. We're going to do that. What we're going to do is we're going to add the two equations, get something, subtract the two equations, get something else. So see here, adding the two equations. Secant theta plus tan theta is p. Secant theta minus tan theta is 1 by p. We write the two equations one below the other. Adding meaning we don't change the signs. Adding meaning we don't change the sign. So what happens? This gets cancelled. So 2 secant theta is equal to, you can understand this. Since it's time, I'm just not saying all this. You can follow all that. Then write the two equations again, one below the other, and subtract the two equations, meaning change the signs. When you change the signs, what happens? Secant theta minus secant theta gets cancelled. So you get 2 tan theta. 2 tan theta is equal to p minus 1 by p. I've written the change signs below here, children. The changed signs I've written here below. I can do it there only while typing. I can't write it here. I can't show them here like this. Like this, I cannot show them. You show them there. You show them here. You don't have to put it below like this. You please show it in the bracket here. So when you subtract equation 1 minus equation 2, when you do equation 1 minus equation 2, you get 2 tan theta, because tan theta plus tan theta is 2 tan theta is equal to p minus 1 by p. Then you can work that and find tan theta. So now you found secant theta and tan theta. You found secant theta and tan theta. What is that you'll have to find? You'll have to find secant theta, tan theta, and sine theta in terms of p. You found secant theta in terms of p. See here, secant theta in terms of p. You also found tan theta in terms of p. Now you will have to find sine theta in terms of p. You'll have to find sine theta in terms of p. All right, sine theta in terms of p. So now we know that sine theta by cos theta is tan theta. Sine theta by cos theta is tan theta. That means when you cross multiply, you get, sine theta is equal to tan theta into cos theta. When you cross multiply, sine theta is equal to tan theta into cos theta. So sine theta is equal to, what is tan theta? See here, p square minus 1 by 2p. Sine theta is equal to, when you cross multiply, you get cos theta into tan theta. Now see below, sine theta is equal to, what is tan theta? This one. P square minus 1 by 2p here. Into cos theta. Cos we don't know, but we know secant is this one. So cos will be the reciprocal of this. We know secant. So cos is what? 2p by, cos will be 2p by p square minus, plus 1. Reciprocal of secant. So 2p and 2p gets cancelled. So sine theta is equal to p square minus 1 by p square plus 1. So whenever you're given one equation like this, secant theta plus tan theta is p, find the other one, secant theta minus tan theta. It will always be the reciprocal 1 by p. We'll talk more about this in the next class. So when you're given secant theta plus tan theta, find secant theta minus tan theta. Write the two equations one below the other, add them, subtract them. That is equation 1 plus 2, equation 1 minus equation 2. So you get secant theta from one and tan theta from the other. So we have expressed secant theta and tan theta in terms of p. Then to express sin theta in terms of p, use this relation. Use this relation and get sin theta in terms of p. Take a screenshot, children. Please write this one here. Secant square theta minus tan square theta is 1. So complete 8 and 9 in your classwork by the next class. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.
Thank you, ma'am.